Now, this is the hard one. 3D reflections, a reflection in the plane x equals 0, y equals 0, and z equals 0. Our diagram from here. We'll start with the reflection in the plane x equals 0. So the plane x equals 0, like I said, we're in 2D drawing, we can't represent stuff accurately in 3D, but this will follow through to here. But that just looks like a line, so it's like a plane, so it's meant to be 3D, so it's like meant to be a plane that's like meant to be 3D. But of course we can't properly draw that here. Now what's the hard bit to understand is that right now this just looks like a line. So if we have this point here, we'll rotate it around the line, so that will map to here. This point here will like map to here. But that's not the case, because again, we can't accurately represent what happens in 3D on 2D drawing. But this is an accurate representation, so thank you ChatGPT. This grey plane over here is the plane x equals 0. This is the z-axis, that's the y-axis. These blue crosses over here are points on the x-axis, and they are being reflected through this plane x equals 0. Now it's not hard to see that this will go all the way over here, this over here, and this over here, through the plane. It's going through the plane. But the z and y axis, they lie on the plane. They lie on the plane, so any reflections mean that it's invariant. Because this is on one side of the plane, it's reflected, it goes through the plane onto the other side. But these lie on that plane, so they can't go anywhere because they lie on the plane where the reflection's happening. They're not on this side or this side. They're on the plane, so they cannot be reflected. So for a reflection in the plane x equals 0, the x and y axis are invariant because they lie on that plane. And it's the same for a reflection in the plane y equals 0. This is the plane y equals 0. This is the z-axis, that's the x-axis. They lie on the plane, so they're invariant. This gets mapped over here. This gets mapped over here. This gets mapped over here. They go through the plane. But the x and z-axis lie on the plane, so they are invariant. And same here. This is the plane z equals 0. The axes lie on the plane, so they're invariant. But this goes through the plane on the bottom here. This goes through the plane over here. This goes through the plane up here. So whatever points, so our identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, it will map to x dash, y dash, z dash, 0, 1, 0, 0, 0, 1, because the y and z are invariant. Here, our 1, 0, 0, 0, 1, 0, 0, 0, 1, the plane y equals 0, that will have the x dash, y dash, z dash, that will stay as 1, 0, 0, and 0, 0, 1. Here, 1, 0, 0, 0, 1, 0, 0, 0, 1 will get mapped to the plane z equals 0, the points will get transformed, so that will become x dash, y dash, z dash. This stays as 1, 0, 0, that stays as 0, 1, 0. Now this x dash, y dash, z dash, like always when we're deriving it, we start with these points. So now if we imagine reflecting this through the plane x equals 0, that's just going to go over here. And because this is the positive side, that's the negative side, so it's going to map to minus 1, 0, 0. If we're reflecting along the plane y equals 0, this is the positive side, that's the negative side, so it will map to 0, minus 1, 0. And same for the z-axis, that's the negative side, this will map like over here to 0, 0, minus 1. So, a reflection in the plane x equals 0, like we said, the points lying on that plane will get mapped, So 1, 0, 0 gets mapped to minus 1, 0, 0. These stay the same as 0, 1, 0 and 0, 0, 1. Reflection in the plane y equals 0. Only the y changes. These stay as 1, 0, 0 and 0, 0, 1. And the j vector of 0, 1, 0 we just did over there will get mapped to 0, minus 1, 0. And the same over here. Only the z or the k vector changes. These stay the same. So that is a reflection in the plane x equals 0, y equals 0 and z equals 0. On 2D I just wasn't understanding why these planes are like invariant for x equals 0. Like why are the planes invariant? Because it looks like a line, like you're reflecting through a line. So a point here will go over here. A point here will go over here. It looked like a line, so I was like, why do they stay invariant? But thanks to ChatGPT, it generated a image that looked more 3D, and you can see that actually they lie on that plane. So everything in this space over here and everything on that space over here is all on the x-axis. The y and z axis are just on the plane. These are through the plane, and it's the same over here. So I hope this was helpful. It definitely helped me, so I'm really hoping it helped you. This is the hardest part, and now hopefully you understand how to derive the 3D matrices for reflections and rotations. Thank you for watching. We'll do some exam questions next video.